Since the time of early civilization, humans have been fascinated by the question, what is light? Each society had its own interpretation. For example, the ancient Egyptians believed light was divine, a life-giving force associated with the sun god Ra. The Greek philosopher Empedocles believed that light was something created by our eyes and sent out to illuminate the world, allowing us to see. During the Islamic Golden Age, a period of flourishing science and culture, a brilliant thinker named Ibn al-Haytham wanted to test these ideas experimentally. He showed that light doesn't come from our eyes, but is actually an independent part of nature that travels into our eyes. This was a major step forward in understanding how vision and light really works. But the deeper question still remained, what exactly is light? In the 17th century, physicist Isaac Newton proposed that light was made out of tiny particles, similar to bouncy balls, which he called corpuscles. However, Newton did not have much experimental evidence to support his claim. He just believed that was the way it was. At the same time, Christian Whewell, another prominent physicist, had a different idea. Light wasn't made out of particles, but it was a wave similar to ripples in water. His main argument? Diffraction, the bending of light around obstacles, a behavior very similar to how water waves spread out. Whewell's explanation was convincing enough at the time, and for a while the scientific community accepted that light was a wave. Fast forward to the 1800s, and a rising physicist named Thomas Young set out to settle the debate. Is light a wave or a particle? He designed a simple but brilliant experiment, now famous as the double slit experiment. He shone a beam of light through a barrier with two tiny slits, and behind that wall was a screen that could detect where the light landed. The experiment boiled down to two main ideas. If light were made of particles, like tiny bullets, it should pass through one slit or the other and hit the screen in two clumps directly behind the slits. However, if light was a wave, like ripples on water, the waves passing through both slits would interfere with each other, combining in some places and canceling out in others, to make a striped interference pattern on the screen. And when Young ran the experiment, he saw the interference pattern. Light was behaving like a wave, but the story does not end there. At the turn of the 20th century, another young physicist named Albert Einstein stumbled upon something that completely challenged this idea. He was studying the photoelectric effect, where light shines on a metal surface and sometimes kicks out electrons. But here's the weird part. Shining a brighter light didn't always eject electrons. Only light above a certain frequency, like UV, would do it, even if the UV light was dim. Lower frequency light, no matter how intense, did nothing. This made no sense if light was purely a wave, because waves carry energy in proportion to their amplitude, their brightness, not their frequency. So if light was a wave, a bright light, no matter the frequency, would eject the electrons. Einstein proposed a radical idea after discovering this fact. Light comes in packets called photons, and each photon carries energy based off its frequency. If the photon's energy wasn't high enough, it simply couldn't knock an electron free. This explained the photoelectric effect perfectly, but only if light was made out of these particles called photons. So now the science world had a paradox. Young showed light was a wave. Einstein showed it was a particle. The only possible conclusion? Light is both a wave and a particle, depending on how you observe it. That is the strange reality of wave-particle duality. a core principle of quantum mechanics. So, after thousands of years of wonder, debate, and experimentation, from the myths of Ra to the ideas of Newton, Young, and Einstein, we've learned that light isn't just one thing. It behaves like a wave, it behaves like a particle, and somehow it's both. This strange truth lies at the heart of modern physics and opened the door to the world of quantum mechanics. Don't forget to like and subscribe so you don't miss the next episode.